If you get hold of two magnets and you push them, you can feel this pushing between them. Turn it around the other way and they slam together. Now, what is it, the feeling between those two magnets?
What do you mean, what's the feeling between the two magnets?
There's something there, isn't there? I mean, the sensation is that there's something there when you push these two magnets together.
Listen to my question. What is the meaning when you say that there's a feeling? Of course you feel it. Now, what do you want to know?
What I want to know is what's going on between these two bits of metal.
Magnets repel each other.
And well, then what does that mean, or why are they doing that, or how are they doing it?
You're asking.
I must say, I think that's a perfectly reasonable question.
Of course, it's a reason. It's an excellent question. Okay. But the problem that you're asking, you see, when you ask why something happens, how does a person answer why something happens? For example, Aunt Minnie is in a hospital. Why? Because she went out and she slipped on the ice and broke her hip. That satisfies people. It satisfies, but it wouldn't satisfy someone who came from another planet, knew nothing about things. First, you should understand why, when you break your hip, do you go to the hospital? How do you get to the hospital when the hip was broken? Well, because her husband, seeing that she had the hip was broken, called the hospital up and sent somebody to get her. All that is understood by people. Now, when you explain a why, you have to be in some framework that you allow something to be true. Otherwise, you're perpetually asking why. Why did the husband call up the hospital? Because husband is interested in his wife's welfare. Not always. Some husbands aren't interested in their wife's welfare when they're drunk and they're angry. And so you begin to get a very interesting understanding of the world and all its complications. In order to if you try to follow anything up, you go deeper and deeper in various directions. For example, you could go, why did she slip on the ice? Well, ice is slippery. Everybody knows that, no problem. But you ask, why is ice slippery? That's kind of curious. Ice is extremely slippery. It's very interesting. You say, how does it work? You could either say, I'm satisfied that you've answered me, ice is slippery, that explains it. Or you could go on and say, why is ice slippery? And then you're involved with something, because there aren't many things as slippery as ice. It's very hard to get. Greasy stuff, but that's sort of wet and slimy. But a solid that's so slippery, because it is in the case of ice that when you stand on it, they say, momentarily the pressure melts the ice a little bit, so you got a sort of instantaneous water surface on which you're slipping. Why on ice and not on other things? Because ice expands water expands when it freezes, so the pressure tries to undo the expansion and melts it. It's capable of melting it. But other substances contract when they're freezing, and when you push them, they're just satisfied to be solid. Why does water expand when it freezes and other substances don't expand when they freeze? All right? I'm not answering your question, but I'm telling you how difficult the why question is. You have to know what it is that you're permitted to understand and allowed to be understood and known, and what it is you're not. You'll notice in this example that the more I ask why, it gets interesting after all. That's my idea, that the deeper a thing is, the more interesting it is. And we could even go further and say, why did she fall down when she slipped? That has to do with gravity, involved in all the planets and everything else. Never mind. It goes on and on. Now, when you ask, for example, why two magnets repel, there are many different levels. It depends on whether you're a student of physics or an ordinary person who doesn't know anything or not. If you're somebody who doesn't know anything at all about it, all I can say is that there's a magnetic force that makes them repel, and that you're feeling that force. And you say, but that's very strange, because I don't feel kind of force like that in other circumstances. When you turn them the other way, they attract. There's a very analogous force, electrical force, which is the same kind of a question. And you say, that's also very weird. But you're not at all disturbed by the fact that when you put your hand on the chair, it pushes you back. But we found out by looking at it that that's the same force, as a matter of fact. The electrical force, not magnetic exactly in that case, but it's the same electrical repulsions that are involved in keeping your finger away from the chair, because everything's made out of its electrical forces in microscopic details. There's other forces involved, but it's connected to electrical forces. It turns out that the magnetic and the electric force with which I wish to explain these things, this repulsion in the first place, is what ultimately is the deeper thing that we have to start, what we can start with, to explain many other things that looked like they were, everybody would just accept them. You know, you can't put your hand through the chair. That's taken for granted. But that you can't put your hand through the chair when looked at more closely, why? It involves these same repulsive forces that appear in magnets. The situation you then have to explain is why in magnets it goes over a bigger distance than in ordinarily. And there it has to do with the fact that in iron, all the electrons are spinning in the same direction. They all get lined up, and they magnify the effect of the force until it's large enough at a distance that you can feel it. But it's a force which is present all the time and very common and is in a basic force of almost, I mean, I can go a little further back if I were more technical, but at an early level, I just have to tell you that's going to be one of the things you'll just have to take as an element in the world, the existence of magnetic repulsion or electrical attraction, magnetic attraction. I can't explain that attraction in terms of anything else that's familiar to you. For example, if we say the magnets attract like as if they were connected by rubber bands, I would be cheating you. Because they're not connected by rubber bands, I shouldn't be in trouble. You'd soon ask me about the nature of the bands. And secondly, if you were curious enough, you'd ask me why rubber bands tend to pull back together again, and I would end up explaining that in terms of electrical forces, which are the very things that I'm trying to use the rubber bands to explain. So I have cheated very badly, you see. So I'm not going to be able to give you an answer to why magnets attract each other, except to tell you that they do, and to tell you that that's one of the elements in the world of the different kinds of forces. There are electrical forces, magnetic forces, gravitational forces, and others, and those are some of the parts. If you were a student, you'd go further. I could go further. I could tell you that the magnetic forces are related to the electrical forces very intimately, that our relationship between the gravity forces and electrical forces remains unknown, and so on. But I really can't do a good job, any job, of explaining magnetic force in terms of something else that you're more familiar with, because I don't understand it in terms of anything else that you're more familiar with.